On the top of that a person is there. This is the another chair, one person. Another chair and one person. Another chair and one person. Imaged like this. Person has been imaged as electron. Chair imaged as the positive whole. So hole and electron are combined together in all the substances. Suppose this electron have been ejected. This person has been ejected. You are getting a vacancy. So what will happen? Automatically this person will jump here, and this person will jump here, and this person will jump here. In the same way, as soon as one electron has been removed from the first one, as chair remains, one hole could have been remained. Whenever the electron lost, a hole could have been remained. Now, electrons are moving in this direction, and holes are moving in opposite direction. So, they are telling that the positive holes in metals are moving in opposite direction. These are the difference between electronic conductors and electrolytic conductors. And you have semiconductors. Semiconductors are conducting current only under special condition. What is the special condition? Either by heating or adding impurities. Suppose one semiconductor conducts the current just by heating, it is called intrinsic semiconductor. Suppose a semiconductor is conducting by the addition of impurities, it is called extrinsic semiconductors. So we can classify like this. Within the extrinsic semiconductor itself, suppose you are having more negatively charged electrons, then it is called N-type semiconductors. Suppose having more positive holes, it is called a P-type semiconductor. N means negative, that's why N-type, negative electrons are more. P-type, positive holes are there. P-type semiconductors. Now let's move on to another topic. Theory of electrolytic conductance. The very first thing is Arrhenius theory. Arrhenius theory. Arrhenius theory. He suggested that all the electrolytes are made of positive ion and negative ion. Suppose this is one electrolyte. It is made of one positive ion and negative ion. Suppose if we throw this into the water, when electrolyte has been thrown into the water, it decomposes to form a positive ion and a negative ion. Likewise, this symbol indicates that it's a reversible reaction. Not only a reversible reaction, it represents that it's a weak electrolyte. Whenever you are putting this kind of symbol, indicates that you are having undissociated salt as well as the dissociated ions. You are having both of them in the medium. Both the undissociated AB and dissociated A plus and B minus. Whenever there is a equilibrium, it is equilibrium exists. You know very well that equilibrium constant can be written. It is also called dissociation constant. The K is called dissociation constant. How will you write dissociation constant? As you are writing equilibrium constant. Likewise. The product has been written first. The concentration of reactant have been, the concentration of product have been written in the numerator. Concentration of product has been written in the denominator, which is called dissociation constant. Arrhenius has claimed that this is constant for all the electrolytes. K is constant for all the electrolytes. And he suggested that the dissociation depends on ions. For example, NaCl is there. Upon dissociation, it forms one Na plus and one Cl minus. So it is forming two particles. And he claimed that the positively charged ion moves towards the negatively charged electrode. The negatively charged ion moves towards the positively charged electrodes. So the oppositely charged ions are moving towards the oppositely charged electrodes. It is the main concept. And he also claimed that suppose one solution is there. The nature of the solution depends upon the nature of the ions. Suppose one acid is there. They are claiming that it is an acid. When shall we call it as acid? Arrhenius is telling that the presence of H plus makes the solution as acidic. Any solution having H plus is acidic. Similarly, any solution having OH minus is basic. Another example, copper sulfate. Copper sulfate solution. As I have told you, it is blue in color. Arrhenius has claimed that due to the presence of Cu2 plus ion, cuprous ion, Cu2 plus, cupric. Cu plus is called cuprous. Cu2 plus is called cupric. Due to the presence of Cu2 plus ion, the blue color has been acquired. He suggested like this. And also he has told that whenever you are using this kind of